This six-story building is not a factory or a workshop. Rather, it is the engine of the world's largest LNG-based container ship. It is so large from the inside that workers can easily walk around within it. This engine drives a propeller whose height is equal to that of a double-story house. And obviously, since it is the engine of a container ship, it must consume a huge amount of fuel. But exactly how much? It consumes 100,000 liters just during startup alone. Amazingly, its fuel tank is so massive that 6 Olympic-sized swimming pools can fit inside it. And it is filled with 20 million liters of liquefied natural gas. Today, you will learn about the construction of a mega project that literally pushed the limits of human engineering. Welcome once again to Noble's Creation. Ladies and gentlemen, we are in the 21st century, yet 90% of international trade is still transported through the sea, whether it is something as small as a needle or as large as a car. You can estimate this from the fact that, according to Flight Radar, at any given time, there are between 15 to 2,000 airplanes in the sky. And if we take a look at marine traffic, at the moment this video is being made, astonishingly, 38,000 cargo ships are traveling around the world. Talking about the size of these cargo ships, we humans have already built extremely large ships. Even larger ships can be built, but then they would not be able to pass through major canals, such as the Suez and Panama canals. Therefore, the competition is no longer about building bigger ships, but about making more fuel-efficient ships. And something like this was done by the French shipping company CMA-CGM. They wanted to build the world's largest eco-friendly ship that would run not on diesel or HSFO fuel, but on LNG. That is the liquid form of natural gas. This 400-meter-long ship has a length equal to 4 football fields lined up. Its width is 61 meters, and its height is even taller than the Qutb Minar. The total weight of this ship equals 7 Eiffel Towers, or 11,500 African elephants. That is 70,000 tons, and that too without any containers. This ship can carry a total of 2,312 containers. To imagine their scale, if these containers were placed in a single line, they would form a 150-kilometer-long queue. But the real challenge was not just building this massive ship. Rather, CMA-CGM had to build 9 such ships, and that too within a short period of just 2 years. For this task, a shipyard in Hong Kong was selected, which is 4 kilometers long and looks like a small city. Here, 6,000 workers from around the world work day and night, and each person is assigned a different task. But the question is, when normally one ship takes 18 months to be completed, how will 9 ships be built in just 2 years? The simple answer is that the ships will be built in pieces, called blocks. The foundation of a ship consists of steel sheets so that they do not rust. For one ship, 12,660 steel sheets were required. These sheets were cut using a special laser beam whose temperature was 18,000 degrees Celsius. That is 3 times higher than the surface temperature of the sun. This laser beam cuts steel just like a knife cuts butter. For one ship, a total of 880 kilometers of steel strips were cut. Then these sheets were joined together to form blocks. These blocks can range from the size of a room to as tall as multi-story buildings. And the amazing thing is that pipes, wiring, and other fittings are already installed inside these blocks. This is the rear part of the ship, which is made by combining 5 blocks. Its weight is 790 tons, equal to 2 train engines. To lift this section alone, 2 giant cranes were used. It was placed with extreme precision onto the already existing structure of the ship. And remember, even a 1 millimeter mistake can ruin months of hard work. Once the blocks were placed in position, the next step is an endless process of welding. Amazingly, A total of 1,250 kilometers of welding was done on one ship. If this welding were laid in a straight line, it would stretch from Karachi to Lahore.
After welding, every joint was carefully inspected, because the ruthless waves of the sea do not forgive even the slightest weakness. So far, this was only the story of building the hull and blocks. The real marvel lies in its engine. This ship does not run on traditional oil or diesel fuel. It is designed to run on LNG. This is a major environmental achievement, because compared to oil, LNG releases 99% less sulfur dioxide, 91% less air pollution, and 20% less carbon dioxide. This is a huge step toward making sea travel cleaner. But if CMA CGM wants to bring this revolution to the shipping industry, they have to pay a heavy price. The biggest issue here was storing LNG in liquid form. That means creating a fuel tank in which LNG remains extremely cold. If it warms up or if the tank's insulation fails, LNG will turn into gas and expand. And then the game is over. This ship has to travel from Asia to Europe without refueling.
For this, it is necessary to build a very large LNG fuel tank. But how large? Amazingly, this is the largest LNG fuel tank in history. Its volume is 18,000 cubic meters. It is so large inside that 6 Olympic swimming pools can fit within it. Overall, it can hold about 20 million liters of LNG. But the real challenge is not building such a large tank. It is protecting this tank from heat. It is just like building a giant thermos inside the ship.
A thermos as large as 6 swimming pools combined. It took about 9 months to build this tank. Multiple layers of insulating materials were applied to its walls. These layers protect the tank from external heat. After this comes the most important stage, leak testing, because it is very important for this tank to be airtight. For this, workers used a simple method. They applied soapy water on the joints.
Then, they placed a glass container over it, and with the help of a compressor, they removed all the air from inside. If the joint is weak, outside air will enter due to the vacuum, and bubbles will start appearing. In this way, leaking joints were identified and repaired. After leak testing, the final insulation layer was applied. This is a special steel membrane, only 1.2 millimeters thick. When extremely cold LNG touches it, the steel shrinks.
A wavy design allows the steel to contract and expand without breaking. And you will be surprised to know that this technology is also used in space stations. Finally, after 8 months of hard work, this masterpiece, the world's largest thermos, was completed. Now, let's move to its engine. This is the largest natural gas-powered engine ever built. It is 20 meters tall, equal to a 6-story building. It weighs more than 2,000 tons. It produces 85,000 horsepower.
It is so large that maintenance staff can walk inside it. Bringing this engine to the shipyard was also a major challenge. It was transported in 6 separate parts. Its most important part is the crankshaft. That is the shaft that transfers the engine's power to the propeller. This crankshaft alone weighs 220 tons. To transport it, a special remote-controlled platform with 140 wheels was used. And it was installed with millimeter accuracy. This engine has 12 pistons with a diameter of 1 meter each, and this crankshaft is attached to these pistons. This engine will drive the propeller installed at the back of the ship. This one-piece cast propeller weighs 92 tons, and its height is 10 meters or 33 feet. The engine's power will be transferred to it through a propeller shaft.
because even a slight misalignment will cause vibrations at high RPM. To check this, a special blue dye is applied to the shaft. Then it is fitted into the propeller. When it is taken out, it shows which parts made contact and which parts did not. This test helps engineers identify pressure points, and adjustments are made accordingly. When the entire structure of the ship was completed, the next step was to protect it from the marine environment.
That is, painting it. Salt water, waves, and friction. After this, the tallest and final block was installed. This is called the command bridge.
This is the brain of the ship. From here, the captain and crew control everything. In this 400-meter-long ship, a system called Smart Eyes is installed, which gives the captain a 360-degree view while sitting on the bridge. Finally, after 1.5 years of continuous hard work, the first ship was ready. During 15 days of strict sea trials, every single thing was tested. The engine speed was tested, emergency braking was tested, and navigation systems were also tested.
At the same time, the entire structure was checked for leaks, and most importantly, its anchor was also deployed and tested. This massive ship's anchor chain is so heavy that just one link of the chain weighs 300 kilograms, and the entire chain weighs as much as 60 African elephants. Finally, the 15-day sea trials were successfully completed. The engineering team's goal of low-carbon emission ships became a reality.
The shipyard won the race against time and completed 9 such container ships in record time. This story is not just about building a mountain of steel. It is the story of the intelligence and hard work of thousands of workers. These massive ships are now ready to rule the world's oceans, and that too in a much cleaner way than before. These mega ships prove that if humans are determined, they can even move mountains of steel through the ruthless seas. We hope you will like and share this video. Thank you very much for your love and kind comments. See you in the next amazing video.